Hello, folks. Welcome back to Merrill Math. I'm Mr. Merrill, and today we're going to be identifying functions. So your first question might be, what's a function? What is a function? Well, there's typically an entire chapter dedicated to this idea of functions, so it's hard for me to define it in a very succinct way. Um, Functions are a lot of things, but I think the best definition that I can give you of what a function is, and the shortest definition, is a relation where each input has a unique output. So, what that means is if you have some relation, some mathematical operation, or some combination thereof, if you have an input, it can only give you one output. So if you put a number in, it gives you a number out. Okay, that's fine. If you put the same number in, it can't then give you a different number because you wouldn't be expecting that. You would be expecting you to do the same thing and get the same result. That is what a function is at its core. So we can look at problems kind of hinting at this idea. So a lot of times what they'll give you are like tables or charts or just a list of values like x, y coordinates. And they say like, could this represent a function? So what we're looking for are inputs that give you an output. So input, output, in, out. For, in, to, out. So in this case, is it a function? The answer is yes. This one is a function. And we don't know necessarily what it does, but as far as we can tell, we don't have any inputs that are repeated. That's what we're looking for. So this is a function because the inputs give you outputs, and there are no repeated inputs to give you something different out. All right, so let's look at some other examples of this. Well, let's look at another example. This is going to be kind of a short lesson. Just identifying functions is kind of a simple idea. But it can be somewhat challenging because it's such a hard thing for teachers to define, and it's also then hard for students to understand. Okay, let's look at another example. While I kick the microphone, we have an input and an output, input and an output, input, output, input. So this is the same input as this, and you got a different number out. So this is a no. That is not a function. Because we put something in, we got something out, that's perfectly fine. We put the same number in, we got something different. That is not a function. So we want a unique output. Now this leads us to the idea of what's called the vertical line test. So sometimes they'll give you graphs and say, is this graph the graph of a function? So the way that the vertical line test works is, and we'll use the marker for this as our vertical line. So the way the vertical line test works is exactly as it sounds. You have a vertical line. So a line that goes straight up and down. So if your line intersects the graph in more than one point at a time, anywhere, then it's not a function. So for this one, this line here, it's sloping downward. If I put my line on here, notice that it's only touching the graph at one point at a time. Here, same idea. It's only touching at one point at a time. Here, we might expect something different, but still one point at a time. That's fine. Now, something that students might have a problem with is, well, this output is the same as that output. The outputs can be the same as each other as long as the input doesn't give you two different outputs. That's what we're looking for. So here we have a graph. Looks kind of strange, but it follows the vertical line test. Here we have one that violates it. So if we were to draw a vertical line, let's say here, notice that it intersects the graph right there and right there. all we need is one instance of this, and it doesn't work. If we happen to have quite a few from there to there, there's 2 points all the way along that. Here, if we draw a vertical line, it intercepts here, and that is a no. So this is a no, this is a no. The rest are yeses. So those are all functions. So if you come across vertical line test problems, basically what it's saying is, does a vertical line drawn through any part of the graph intercept the graph in 2 or more places? There we go. That's the way to say it. Okay, so if you have any questions, comments, points of clarification, you can leave those in the comments below. If this video helped you out at all, you can leave it a like. If you would like to see more, please subscribe. Otherwise, thanks for watching.